Hello, everyone. Today we're going to be talking about in 7.4, we're talking about the normal distribution. Now, the normal distribution is kind of as described below, actually. This is what you guys have probably seen this actually. It's known as kind of like the bell curve. And it models actually a lot of things that we're going to do in real life. But it's obviously continuous. The mean, median, mode are all equal in the normal curve because it's 100% symmetric for this graph. Now, when it comes to the normal curve, how it's typically divided up is it's kind of divided into think of like regions. And it's all based on kind of what the mean of the graph is. So the mean of the graph you'll see is right at the very center of the bell curve. So one of the things that we're going to be doing is we're going to actually be creating our own normal graphs, our own bell curves in this case. So how we start, you guys are going to get a really good some practice on drawing your bell curves. But we're going to start by just drawing kind of just a baseline. I'm going to do my best. I'm not that great at drawing bell curves, but you guys can probably do a better job than me. But the first value that we're going to find is kind of like the middle value for our graph. So depending on the problem, it's all based on what the mean of our graph is actually going to be. So for this graph, it says a normal distribution has a mean of 45.1 and a standard deviation of 9.6. So how it's divided up is obviously the mean is always going to be the center of our graph. So 45.1. And how the rest of the curve is divided up is all based on what the standard deviation is. Because if you'll remember, when we say standard deviation, that's the distance that all the average points in your data set are from the mean. So how we create the other kind of sections in here is obviously right now 50% of the data is on one side, 50% is on the other, but we're going to divide it up into kind of smaller regions here. And it's all based on when we take the mean and we add our standard deviation to go one direction, or vice versa if we subtract it to go the other direction. So here, if I know my mean is 45.1, it also tells me that my standard deviation up here is 9.6. So this is the distance that your different sections will be from the mean. So all we do is we take 45.1, and to find kind of the value of our next section, we're going to take 45.1 and we're going to add, ooh, that 6 went crazy, add 9.6 to it, and that's going to give us 54.7. And you just found kind of your first region. Now, typically we'll do at least 2 or 3 iterations. So let's do 2 more, just so we have it broken down even more. So 54.7 plus another 9.6, that's going to end up being 64.3. And then we'll do one more. If I take 64.3, add 9.6, that's going to find me my next region, which is going to be 73.9. And we're going to do the same thing the opposite direction. 45.1, it's just I'm going smaller. So I'm going to subtract whatever my standard deviation is. So 45.1 minus 9.6, that's going to leave me, woo, with my next region of 35.5. Subtracting 9.6 again, 9.6, that's going to tell me what my other region is now going to be, which is 25.9. And again, we're going to go one more in this case. If I subtract 9.6 one more time, that's going to leave me with 16.3. Now, because you did your standard deviations evenly on both sides, all of the percentages up here actually still hold true. The area under this curve, there's about 34% of the area, which is going to be in here, 34% of your data, which is going to be in here, 13.5% of your data is in there, 13.5% is in here. And then in that last section, there's going to be about 2.35% in each of these guys. So for those, I just copied those percentages from up here. These values are the same in every single normal distribution curve that we work with. And what we can do is, now that we have our normal curve for this scenario, we can now go through and kind of answer some of our questions. So part A says the middle 99.7%. Well, you guys look, I do also have kind of the general percentages up here. That's how much is in between each of those individual values. So if I'm asking you the middle 99.7%, we're looking at what's between the third iterations here. So really, the values that are the ending of this, we would say we're between our first value, which is about 16.3. So up here, we're going to be between 16.3 and the upper level of that curve, which was 73.9. And that's where the middle 99.7% of our data is. Similarly, we do kind of the same for the rest of this. So I would still go through and we would say, okay, well, where's the middle 95%? That's between your second iterations up here. So my second iteration, that's just kind of one, or excuse me, technically 2 away from the mean. So I'm going to be between 25.9 and 64.3. So 25.9 and 64.3. And then the middle 68% of the data is in between the first iterations. So we're going to be in this case between, whoa, I spelled that wrong. All right, so between 16.3, or no, wow, sorry guys, 35.5 and 54.7. And that's going to work pretty much the same way for all of our normal distributions. Now, if we're finding the percentages, this is now where these percents kind of in the middle of the graph are going to come in, where they're going to help us here. So it says, what percent of the data will be greater than 54.7? So if I find my 54.7 on my graph, that is from this part of our graph on. So what percent is greater than that? We are going to look through and we want to total up the percentages that are in that specific category. So greater than 54.7, that means we're going to work with 13.5 and 2.35. So 13.5 plus 2.35 is going to leave me with 15.85% of the data is under that part of the curve. All right. So what I want you guys to do is I want you guys to pause your video and I want you guys to try finding your percentages for E, F, and G. All right, final answers are up. So really you're going to be just looking for those values in your different standard deviations away from your mean, and you're just calculating those percentages. Now for when we take our quiz on this, you guys are going to be given those percentages. You don't have to memorize those. You are going to have to know how to create these values right here. So let's do one more practice problem with this part. So it says a normal distribution has a mean of 38.3, and actually I might go down below and we're going to just do it on the next one. So in our next example, it says students counted the number of candies in 100 small packages. They found that the number of candies was normally distributed with a mean of 23 candies per package and a standard deviation of 1 candy. So our normal distribution curve is going to actually be a little bit simpler than the last one. And then just draw our, to the best of our ability, as straight as possible. And we're going to start by dividing our normal curve with whatever the mean is, which is 23 candies. And since my standard deviation is only 1 piece, that means we can create our next couple of regions right now. Just if I add 1, we're going to be at 24. Add 1, we're going to be at 25. And again, we usually do 3 standard deviations. So let's end at 26. And if I go 3 in the opposite direction, we're going to be at 22, 21, and 20. So kind of the same thing as before, those percentages above, if you like writing them in there, you can. It's going to be 34% here, 34% here, and then you're going to have 13.5. Sorry, guys. 13.5% here. And then in the last one, it's about 2.35. There is more, or there is a little more that are like in the areas in these regions over here after the third iteration or the third standard deviation, but they're almost negligible. Almost all of the data is really under this section of the curve, which is kind of crazy. So for our first question, it's telling us about how many packages have between 22 and 24 candies. So that's telling me I'm really looking at this area of my graph between 22 and upward. Ooh, that's not supposed to happen. So it's between 22 candies and 24 candies. That's this section of the graph, which is, if I add my percentages, I'm going to take 34 plus 34, and that's going to be equal to 68%. So if I wanted to see exactly how many packages, we would take 0.68 times the number of packages, which is 24. Or I'm sorry, there was 100 packages. Times however many packages there are. And that tells me that there's about 68 packages. All right, that have between 22 and 24 candies. All right. The last one says, what is the probability that a package selected at random has more than 25? Well, more than 25 would be this section of the graph here, which would be 22.35 and beyond. Like I said, that last section is kind of negligible. So we would just say about 2.35% of all the packages. So if we take our 0.235%, multiplied by the number of packages, that leaves us with about 24 packages. Oops, sorry guys, I was looking at the wrong problem. Not 24. 0.235 times 100 is definitely 2.35. So in this case, since it is a decimal, we are just going to round it. It's about 2 to 3 packages. Not exact, because we don't know exactly how many packages had that many, but based on just the average of this, it's about 2 to 3 packages. Okay, so that is your introduction to the normal curve. You can now go ahead and start the homework for today.